In this video, we're going to learn how to convert between logarithmic and exponential equations. So to begin, let's talk about what a logarithm actually is by definition, so that we know what we're dealing with if we're going to be converting logarithmic equations into exponential equations. By definition, a logarithm is, first you have to know you have to let b and y be positive numbers. So they have to be positive values to start, and b cannot be 1. With that being said, the logarithm of y, so notice we have logarithm of a number y with base b, you can see that the base b is denoted there, by y is defined as the following. So this is really what a logarithm is. It's where a logarithm is created from. So here if we have log base b of y, which you can see here, and it equals x, it has a special relationship with an exponent where it becomes b to the power of x equals y. Now, essentially, logarithms and these exponentials become inverses of each other. And I want to show you how they're related and how you can flip between the two forms. So I'm going to rewrite them down here. So we have log base b of y is equal to x. And we can rewrite that as b to the power of x is equal to y. In these two statements, b, x, and y are all the same. It's two different ways to write the exact same expression. Now what you're hopefully noticing here is that we have log base b and we have an exponential with a base b. So as we convert between the two forms, they both contain a base of b. And then what I notice happens is that the x and the y kind of change location. Where it used to say equals x with a log, now it says equals y with an exponential. And then we had y inside of the log. Well, now we have x inside of the exponent. So there's a little switcheroo happening here. So a logarithm has a very, very special relationship with an exponential. So again, remember, they have the same bases. And then essentially whatever is inside of the log goes on the other equal sign of the exponential. Whatever is inside of the exponent goes inside of the log. So this video is going to focus on how do we actually rewrite these into the opposite form. So for each logarithmic equation that you see here on the screen, we're going to convert it into its exponential form. And the reason we're going to practice doing this is because later on we will actually be able to solve equations with x that contain logarithms or exponentials. We'll be able to rewrite them into different forms and actually solve them. So to start here, remember these are the two equivalent statements. They both have a base of b, but the y and the x kind of flip sides. So here you can see that we have log base 2 of 32 equals 5. So if we're going to write it into an exponential form, remember this base value of 2 is also the base of your exponent. So I have 2. I then have my x value on the other side. That's going to go into my exponent, which is 5. And then we're going to have that equals what my y value is of 32. Now if we attempt this next one, again, remember base value is the same. So we have a log of base 3, so we have an exponent of base 3. This 5 goes into the exponent, and that equals our y value of 243. Now notice if you read through these expressions, 2 to the 5th power is 32. 3 to the 5th power is 243. This next part here, we take our base, which is 1/4. So the base of our exponent is 1/4. I'm going to put that in parentheses because it's a fraction. It's to the power of -2. And that equals 16. And then this next part here, we have a base of 5 to the power of 0 is equal to 1. So remember, x and y flip, and our base stays consistent. Now, these are pretty simple when you have numbers. Where it gets interesting is if you have something like the following. So say you had something like log base, 2x, and then we'd have, say, inside the log 3x minus 2 is equal to 2x plus 4. I mean, that's a lot going on there, but if we had something like this, you can still rewrite this into exponential form. It's the exact same process. Your base of your log becomes your base of your exponent, which would be 2x. That's our base. And then our x value over here, which is the entire thing, notice it's whatever the log is equal to, would become our exponent. So that becomes 2x plus 4 is equal to whatever our y value is, which is what's inside of this entire log here, of 3x minus 2. Now obviously this is a very complicated looking equation, but you are able to take it from its logarithmic form and write it into its exponential form just by using those basic patterns of how logarithms and exponentials are related. Now on this slide we're going to do the exact opposite. We're going to take the exponential equation and we're going to write it into its logarithmic form. So here we can see we have the base of our exponent becomes the base of our log. So this would become a base of 6. We have log base 6. Then we take what our y value is equal to here, which is 36, and that goes inside of our log. So we have 36 is equal to 2, the x value in our exponent. We then repeat this process on the next one. Our base of our exponent is 16, so the base of our log is 16. Inside of our log is the value on the other side of the equal sign, which is 8, and that's equal to what's currently in the exponent, which is 3/4. We then move on to the next one. Here we have our base of 4, so log base 4. Then the 1/16 is what's inside of our log, because that's on the opposite side of the equal sign. And then what's in our exponent becomes what we're equal to. And then finally here we would have log base 2. Then what's on the other side of the equal sign goes inside. That 64 equals 6. So just understanding that simple relationship is going to help you convert them. The bases are the same, and then what's inside the log here becomes what's on the other side of the equal sign. What's inside the exponent here becomes what's on the other side of the equal sign here. So if we want to look at a slightly more complicated one, we can kind of make one up. So say we had something like 14 to the power of 3x plus 2 equals 2x minus 4. Again, really complicated, but we can apply this same process. So remember, our base here is always the base of our log. So we would have base 14 for our log. Inside of our log, we would have what's on the other side of the equal sign, that entire statement. So 2x minus 4. And that's equal to what's currently in our exponent here of 3x plus 2. So again, the big things are their bases are the same, and then essentially what's inside becomes outside the equal sign, what's inside becomes outside the equal sign. They basically do a flip of what's located inside of the math operation and what's located on the opposite side of the equal sign.